Okay, so hi everyone. My name is Alexey Buzdin, and what do I do here and what I do for a living? So basically, I work in Bank Citadel. I do stuff there, and also I try to organize different kind of events like GDG Riga, like Druk and Riga Dev Days, also Mobile Development Latvia. So what we're going to talk today about, we have the topic testing RESTful services. And in this talk, we're going to see what kind of problems there is with RESTful services, how you can bypass them, and we'll try to learn a couple of cool new technologies that you haven't heard before, hopefully. Yes, by the way. So, and let's start with the tail to understand why we're talking about it at all. So, a long time ago, we had spaghetti architecture, right? So we had a big monolith of code, which was really tightly coupled together, and you can just like deploy it to. And how you actually could test such a thing. So 15 years ago, you could do some monkey testing. You could click, 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 enter, click, click, and that's it. Then JUnit appeared, you could start writing some automated tests, you could write Selenium tests, etc. So the next evolution of projects become the, how it's called, lasagna architecture. When you had layers of your source code with persistent layer, with a service layer, with UI layer, etc. And this allowed us to test integrations. Like we take two layers and test if they correctly interact with each other. So newer architecture styles allowed us to test newer stuff, and we had to test it to be assured that it's working correctly. So now, and yeah, so there could be different kind of tests like UI service unit, and actually the higher we go, the higher the effort and the higher the cost.
Web UI, and we treat each microservice as a separate application that is a black box. It has an input, it has an output. So if we're testing input of a web application, let's try to test input of microservice and see what it provides. So for us, I would say to test the microservice is to test this API. And luckily, we have the contract for API, which we have to deploy. So why API test? First, we need to test routing inside the microservice. So 15 years ago, how would you write a web service? You would have a servlet, right? So you have one single method called service. You get a request, and you need to fill the response. If you want to do different status codes, you need to pass it to response, set it yourself. If you want to read status codes, you need to read it yourself from the request and create if statements or case statements or whatever. So you would have here a big pattern match for all the request parameters like headers, status codes, headers, HTTP methods, etc., etc. Nowadays, it's a bit simpler because we have things like Spring, things like Jersey, etc. When we just say, okay, this is a controller, this is a mapping, everything should work. Right? But when we start relying on annotations, we are not controlling the process, and actually we don't know how it works. So here, how we can test the request mapping. Yeah? If we create a simple controller and we test only the get method, we haven't tested the if statement, then when anyone is doing a request on slash and it's a get, it should get here. So this part we are missing. And actually that's a couple of strange bugs, and like not bugs, but features that you could not expect from an application. Like in Jersey, I had an experience that if you are using the same URL, the same HTTP method, but you are using different content type, it will, how was it? if you enter a default message without content type, it will try to get the last method. So if you provided a get method for JSON and PDF is the bottom one, then when you do a get request from a browser, it will get your PDF. And this kind of stuff. So they are not expected, and you cannot control them without doing tests for the mapping. So next is serialization. So when we have MyBin here, we're relying on what was the mapping? JSON was for XML, for JSON. Jackson. There was also the newer one in the JDK7 from JSON E. Whatever. So here we're relying on the framework that does the serialization. We don't know how it works, and actually different frameworks works differently. And also maybe you want to support more interesting cases, like some frameworks have a configuration to treat an array the same if it has one element, it can omit using the brackets. So when you do a post request, it has brackets and has two elements is the same, one element is the same as if you provide just one element. So this kind of configuration is also not clear if you're playing with it, or how to treat, I don't know, do you want to omit trailing commas in lists or not? By default, for example, for some members, they'll throw an error that the JSON is not correct. You can configure that it will just omit it. So this kind of non-transparent stuff, you cannot know in advance. And actually, we had a couple of bugs with this kind of configuration. That it worked for some JSONs, it didn't work for others. But we thought that everything is okay. So we have to test those. So next, testing service responses. So within Java code, we are not writing unit tests on different status codes. For example, is it okay? Is it forbidden? Is it created? Or anything else? Because it's quite hard to do it from JUnit without starting up container. Because we need to start up, so for example, Spring context and some. Yeah. And somehow trigger the annotation of Spring, of Jersey, etc. So they are not triggered by default if you just create an object with new, right? So only with HTTP requests you can test what kind of responses and status codes are happening for different kind of inputs. And also, this API test could be outsourced to QA, who do not know the code base, but they know how HTTP works. They know that if they're providing a wrong JSON, they should expect a bad request. Right? And actually, you can write this code only by specification. You don't need to know the environment. You don't need to be an expert in Java, in Spring, and anything else. You can write those API tests for any server of any language. So let's start to think how we can make our microservice, RESTful service, usable for testing. So first, if we look at this landscape, usually we have everything tightly coupled together. That one microservice uses a message broker, uses a database, uses another microservice, etc. And when we try to start it up, it has all those configurations to access different modules. And it will fail if they're not start up as well. Yep. So we can use, for example, Docker Compose and start up the whole cluster of all the microservices. But this usually is not a good idea, because if you have 3, okay, you started up 3 instances, but if you have a cluster of, I don't know, 10 different microservices, would you like to start up 10 microservices with any code change? Likely not. So first is to decouple integration from your app. So when you design a microservice, you should invest your time into make all the integrations pluggable and open. What do I mean? For example, there is a project called Spring Integration. Who has used it? Okay, great. So Spring integration allows you to configure all your integrations in interfaces. So what do we do here? We have a request gateway interface like this, and it has a method that inputs a request, a string request, and responds with a string. Here, in configuration, we say what does this method do. And here, it is actually an HTTP call with a post method on this given URL. In production, for example, it will work this way. If you want to run it on your local host or as a development environment, you can easily set up a mock here. When you start it up in a test, you can also easily mock and provide all the information you need for testing without doing some Makito magic or power mock magic, mocking status. Sorry? I will talk about WireMock a bit later, because WireMock is how you can set up a mock server. But this, how you can decouple it and make it like, it's like dependency injection for integration. Yeah? So you can inject either an instance of a database, either an instance of another server, or an instance of a message broker. So, what next? When we have this stuff decoupled, we can even decouple it without the Spring integration, but by doing simple Java interfaces and then providing implementations with dependency injection. Then we can just override dependency injection modules for tests and provide HTTP mock realizations. So here we have a handy library that, with a small command line application, also has a Gradle plugin, a Maven plugin, can set up a mock server. So here, what does it do? You say Java mock runner HTTP port and provide the JSON. And in this JSON, this is actually a schema saying what kind of requests it will grab and what kind of responses it will answer. So here, if you do a request on any URL with JSON full bar, it will respond to you with text foo and OK status code. On any else requests, it will return nothing, like 404. And you can easily configure different kinds of stuff. And it's also available from the Java API. So you can start up different mock servers from the JUnit tests. Yeah? And the same is with WireMock. So with WireMock, you can say that you want to create a stub server that will trigger when you do a request on this URL with header accept equals to text XML, and then you will return a response with status code 200 with this kind of header and with this response. So this will allow you to stop using actual instances of integration servers or databases or message brokers. So for database mocking, it's a bit complicated. So I don't have a great solution how to mock a database. So first you can use a string integration, or you can use like just mock repositories with your dependency injection, or you can just substitute your actual database with in-memory one, like GPA, or like with H2 or Derby or HSQL. And if you have Hibernate, you can just easily recreate the schema. You have the entities, you can use them both for actual database, Oracle for example, and recreate the same kind of state for in-memory database. Of course, there will be some problems. What else we can do? We can have a start up a clean instance of database for testing, user Docker for example, and have all the scripts in our liquid-based and flyway just starting up. But this is take some time. You can reuse the same developer instance for testing purposes, which is not that good, or you can just mock all the data from your file system or memory, right? It's just the same stuff we did with mock or WireMock. So we put aside all those integrations like web services, message broker, database, and now we have a complete clear installation of our server. And now actually we can start to test. So first, if we want to create a test for our application, we should somehow start it up. And the question is, how do you deploy your application? If your application is using Spring, then everything is easy. You can just say that you have a Spring JUnit 4 class runner. It will run all the context of Spring inside your JUnit test. You just need to say what kind of port are you using. That's all. Your Spring context is set it up, and when the test is working, you can access by HTTP by the following ports all the URLs of your application. If you're not using Spring and you're using just var files, so one thing handy that would help you is Aquilion. Who has used Aquilion? Okay, not that many. So Aquilion is a library that allows you to configure how you can create your var file with a shrink API. So we say create web archive. You can add classes here. You can add libraries from Maven, for example. So there's API like add all dependencies from Maven. You provide link to ComXML. You can set web XML location, etc. And with this, you've created the web archive, and you can do deployment. And Aquilion supports different kinds of application containers to start it up. So it supports this Tomcats, Wildflies, and Glassfish. And it allows you to create even a cluster. So you can say that please start up a cluster of Glassfishes. And it will start up 2 Glassfish, or 2 Tomcats, or 3 Wildflies. And you can start testing. So, what next? So now we have our application started up in test, because Aquilion is also used in test. Yeah, you see the standard JUnit annotation run this. So we have our context of application that is serving HTTP calls during test phase. So now we just need to write tests. How we can do it? For this, we have a couple of handy libraries. For example, RESTful. Who has used it? Okay, almost like half of people. So RESTful is a great tool that allows you to do HTTP calls and do assertions with standard Humphreys annotations. So here, what do we say? So it uses BTD syntaxes like style of API with given when then. Given is a precondition, then you can configure everything. So here we configure the port of our call. We can use some configuration for object mapping, for example. We can say how we want to serialize and deserialize JSON. We can say what is the URL of it. We can say how we provide authentication options, etc. Then we say when we do a GET request for HealthCheck, that status code should be 200. And we can start this test with a running Spring context or Aquilion context, and we'll get the result. So more complicated things. Here, for example, we have an example of the given configuration. How can we configure our requests, the post request, with additional parameters, adding cookies, adding headers, adding body. So we can do anything we like, anything we do in Postman, we can do in RESTful. And here, we are doing assertion. So we say header content type should be application JSON. And at any point, if we do not like the syntaxes, we can just get either a header or a body or anything else. So to a plain Java string, for example, and test it further with JUnit or AssertJ or something. Next, if you're not a fan of JUnit or if you're using Spring, they also have a similar approach to test web services. They have Spring MVC test. So it follows the same principles as RESTful when you create an MVC and then you can do requests on URLs. So perform for login on default and expect authenticated with user admin. So those are also customizable. You can provide different parameters, headers, and stuff, and expect using compressed matchers and standard chaining operations and sessions. So one hint from my side is, if you're doing this API test, try to make them configurable and try to externalize all the ports on your end. Why so? Because usually you are testing it in a local environment, then on maybe you have a dev installation that developers use or testers use. You would like to run the same tests on the outdated system, right? So you need to have easily changeable URL ports. Maybe you have a bug, you want to run the same test case on a training environment. What else? So now, let's try to test a simple RESTful service and understand what kind of test case we can write with this REST assured and with this API. And as an example, RESTful service, we need to think of some domain, right? And I took this domain, Game of Thrones. So writing root is pretty boring. Writing root of Game of Thrones is not pretty good. So, and we have a resource called house. House Bretian, house start, and house Bulgarian. What can we do? Let's write root, right? So post, get, root, delete. We'll start with a post. How can we test post of resource houses? This is an example. So we are using REST assured. We say, given body, we provide our JSON request. So we have name, we have lore, sigil, words, etc. We post it to houses and we assert that a write status code was received. Right? And by the way, so this is also a cool thing. There is a technology like a framework called human JSON, HJSON. And it is written here with human JSON. So you can omit all the commas and stuff, and arrays are a bit simpler, etc. So if you need to write any configuration or this kind of tutorials, you can use this human JSON to make it easier and readable. Okay, so what do you say? Is this test is enough to test post on this URL? Did we test it properly? Are we sure that everything is working?
What do we want to test?
What exactly? What do we want to test? So here we're just testing a status code. And we don't know. Maybe this is just a default response. Even if an error has happened on application server, it will return to 101. We don't know, right? What we can test. For example, it's a good practice to return a location header, where this item was created and how it can be accessible, by which URL. Yeah? So if we go to URL like API Iron Throne, we should get the language types for this season. And then, so we know this location, and we know that it's an existing URL. What we have tested in such a way? We've tested that application starting, right? Because we don't have 404. We've tested that resource collection exists, because we didn't get an exception when we tried to post for houses. We know that JSON is parsed successfully, at least it's not throwing us bad requests, and there is no validation errors. So all the mandatory fields are there, all of those fields we don't know, all the formatting is proper. But we haven't tested if resource was created on the server. We don't know. Because everything that was returned is the status code and location header. How we can actually test it? After doing post, we can extract the location and then do a get request on location. If we get 200, we know that if we have a test case for just get of a non-created item and it's 404, and here it's a 200, hopefully everything working correctly. But again, we have a problem. So we've tested that the resource was stored on a server, or at least server knows that there was a new addition to the server. But what did we miss? Who can say? What else can we check? Yeah? So we know that something was created on the server, but we do not know what was persisted. Maybe some kind of property was not persisted on the server. So what we can do, we can get the body and assert with the body. And here we're trying to understand if everything we sent was persisted into a database and now read. And actually we had a couple of problems like this with having this exception. So what is the problem? Unicode is the body in a database. And we couldn't have tested it without writing a test case that posts something and then reads something. Or we could miss some kind of property because we didn't write it, a binding for it in our service logic. So it is in the serialization in the entity, but it isn't stored. Or it doesn't have annotation in our GPA, right? So we can pass actual data. But here goes the tricky part, that we should not test the quality of server responses with the requests that we're sending. Why? Because there could be properties that are generated on the server, as there is no way for us to know what kind of information they will provide. Like created on, updated on, generated IDs. How can we get to them? We cannot, because this is a black box, it exists somewhere. We should either create some mocks, provide it into the interface, and somehow like configure them also by accessing RESTful services of mocking dates or something. So this is complex. And you can omit those and just like do not test the quality. Just test for containers. So you can test using JSON class and say that if you persisted this JSON, you would like to have a property name Lannister, lore.sigil equals this, lore.forwards equals this. And actually, like JSON class is a really great tool if you would like to test different scenarios. Your test will be much less polluted with all the information that you should provide to like test the quality for JSON. Yeah? But here again comes the tricky part. If we want to test header, I wanted to test arrays, what is the problem here with arrays? Who can say?
The order.
The order. And should they be ordered in this way? We don't know, right? Because they are only in this way if we put an order by in our database script. Yeah? So, in my past work in CityCode, we implemented a separate tool for testing RESTful services with a Cucumber DSL, and we had to deal with this kind of problem. That we are not allowed to rely on indexes. We need to do filter operations and find the exact information. It could be here, it could be here, it could be here. Because it's not a good idea to put order by everyone. Because actually, you need it only for tests. You don't need it for users. They don't care in which order the information is returned. So you can either implement an order for your arrays, or you can use contain structure. It says that this array should contain Cersei or Tyrion. So what next? To sum up, this is a black box, right? And writing those tests, we need to do a lot of stuff to verify if really something that we saved is saved, or if something that should not exist exists. And always try to prepare your test data for yourself. Do not rely on something in a database. Why? Because you would like to run your tests in parallel. And when you start running all those tests in parallel, or do the stress testing, for example, if you're relying on the same data, which are updated, deleted, added, updated, deleted, you will have problems. you will have random problems in your build when the moon set up in this way that something was deleted before it should be deleted or something, right? So let's think of additional examples of what kind of tests we could write for our application. So we could test, so we covered this, that if an item created successfully, it should return a 201. Next up, we could test if we're missing a mandatory property. So if we're missing a property, server should respond us with a bad request. If a validation fails, it should respond us with bad request and provide what kind of views are failed. Right? If resource already exists, we should get a conflict, for example, if we do some optimistic locking. Why do we need this kind of stuff? Because sometimes, and if the teams are working independently, and if you have more than one consumer, if you're solving 500 internal errors every time, it's quite hard for people who are integrating with you to understand and handle all those pieces. So you need to be curious about the state of your server and what are you doing and how it's reacting to the input. And the same for supported media types, for example. Maybe some of your servers support XML, some of them not. So at least you should create one test like this. Maybe even you want to test that default media type that is returned is JSON, but you also support XML. So you should expose all those errors and conditions to the client in RESTful way. Only then he'll be able to understand the error without affecting you and coming to you and asking why is this error on your server. So if you expose everything clearly without passing spectrators, of course, it would be much easier for a person to understand. So what can we do with get? With get we can do OK, we can do not found, we can do unsupported media types again. With delete, we could do not found, OK, forbidden. For example, if someone else is using the resource. With put, not found, OK, bad request, forbidden, etc. So as you can see, even with one single resource, if you want to support all cloud operations, there's a lot of problem and effort to test all those status codes, headers, etc., etc. If you add one header, you add at least 4 different test cases of how your application could react. And I'm assured that if you have RESTful service, some of these cases will not work for you because you haven't thought that someone could ask an XML of your application, and maybe you will just throw a 500 because you haven't thought that someone could ask you for an XML. Yeah. Another thing that you can do is to invest into describing your API. So here we did it that it provides sensible output, but we can also do some static description. And with this, there is a cool stuff called OpenAPI, earlier called Swagger, that allows you to create JSON files that describe your API. And here you have all information about all your resources and what kind of requests and responses they do. So for these requests, they do this kind of response, etc. And this information is available in runtime. So any consumer that integrates with your server can access the Swagger JSON and check whether all the features that he wants to do is supported. Yeah? So another option for this would be using H2S, for example, when this schema is already present in the RESTful service itself. But with Swagger, you also get the Swagger UI and cool playground. When you see all the resources, you can play around with them. Actually, you can, if it's supposed, you can open it. You'll get a text area. You can input JSON there and simulate the request. Right? If it's a get, you can also simulate stuff, provide different headers, and play around with it. And there are tools that will, for free, create this Swagger schema for your RESTful services. If you're using Spring, there is Spring Fox. And Spring Fox will scan all your Spring MVC annotations and with them construct this Swagger JSON, which is quite cool. So you only need to register it and you have a free Swagger description of your old RESTful API. If you're using Java EE or Jackson, then there is Jackson REST Analyzer, which does the same stuff. So it analyzes Jersey annotations, Jackson REST annotations, and then constructs the Swagger JSON, which you can use. So alternative is how to describe your API. There is Rumble and API blueprint, but with them you need to write actually those documentation yourself. So Swagger allows you to generate it and that's it. Here you could take it as an approach for you write your specification and then you adapt your code. So next, how to deal with asynchronous problems. Because sometimes your code, your server, will not respond data synchronously. And handling asynchronous behavior for RESTful services is not that simple. Because you don't know, you're running your stuff from a JUnit, and JUnit is synchronous. So you cannot wait and wake up at some point when you receive the response. So how you can do it? There is a library of utility from the same guys who did RESTful. And what do they do? You can say await until and say a predicate. How much would you like to wait? For example, here you can wait until Lannister is not moved. And getHouse Lannister is actually HTTP method to some kind of URL. And you can configure it further. You can say what kind of interval would you like to say. You can say what is the delay. For example, you would like to wait 20 milliseconds before something happens. Yeah? Or you can say that you want to test a property. So hasProperty is actually a hamQuest annotation. So you can also put any hamQuest metrics here. Right? Or you can say that you want to only trigger it 5 times. If in 5 times nothing happens, that the test failed. What next? So all the RESTful features that you can use when you test your application, and they are also supported in Spring MVC. So you can use authentication mechanism. It supports both form, both basic, both OAuth 2 authentication. You can also put some certificates. It can bypass proxy, so you can configure it. It has JSON schema validation. So instead of just checking fields, you can say a GET request and validate the schema if all the properties are there and they're in correct format. So you can have multiple headers and cookies, which is actually not all framework support. And I'm proud that RESTful can do those kind of things. You can also send multi-part form data. What do I mean? You can send files and test them. And you can have filters. Filters in RESTful are like aspects when they grab your response or request and you can put data into it, somehow handle it. So what are the points made by this presentation? So in addition to unit integration tests and UI tests, try to think about handling API and testing it as well. So design your app with integration easily mockable and pluggable, so you won't have problems running it and testing it with any of this kind of tests. Unit integration doesn't matter. Decouple the settings of this integration externally so you can easily mock them. Never use equal to compare server responses. So you cannot be assured that the same JSON you are waiting for will be provided back. Maybe something will be something happened with white spaces, and instead of white spaces, it will not have white spaces. Yeah. So you should test with JSON test. So don't rely on existing data. Prepare once yourself, then you can have it comparable. Yeah, so do test in parallel, invest in having a descriptive API, some kind of representation, either it's a Swagger, Dremel, API blueprint, or HealthCheck, and use JSON pass, XPath to assert the results if you want. And here is just a cheat sheet of all the tools that I talk about that I would recommend you to look into. Yeah? So, last but not least, tests are made for you to feel secure. Like a lovely car. So, thank you all. This is all from my presentation, and please ask your questions. Yes, sure.
You mentioned something about the database walking injections. Did you?
Yes. Well, I said that if you have repositories, there are interfaces, and you can inject mock interfaces, like implementation for repositories, if you want.
No magic wand?
No magic wand, yes. Any other questions? Yes?
Why didn't you mention Spring Cloud stuff, like Spring Cloud contracts and RESTdocs? They work well together. They use part of the goodness you showed, and they kind of solve quite a lot of problems as well.
Why I haven't mentioned Spring Cloud? Because here I try to speak not about Spring, but generally about everything in Java. Like, I have stuff about Java EE, I have stuff about Spring. Because most of people write Spring right now, I guess. Who writes Spring? Who is writing hand? Okay, who is not writing Spring and some other stuff? Yeah? So these guys cannot use Spring Cloud. So this is why my translation doesn't work. And we actually use drop wizard. We cannot use it in Citadel at all. Right? Yep.
You mentioned that you used Swagger as a description of your REST API.
Yep.
So this is your contract. You provide it for third parties to integrate with. And do you test this contract?
This contract is created automatically by Jersey or Spring MVC annotations. So it is always up to date.
But is it quality good enough to provide it for customers? These API descriptions, these method descriptions, payload examples.
Yeah. We even use it internally if we do not provide it to customers, because the Swagger schema is helpful for testers. Because in the last projects that I worked, testers were writing test cases with our custom-proofed API test engine by the Swagger specification. So they don't know what is happening in the black box, but they know that these are the contracts, this is the get post, and you can test get post with different JSONs. But if you want to prettify your Swagger, you can put additional extra annotations. It's not that fast, but you can do it pretty if you need it. Yes?
Somewhere in the beginning there was three letters BFF. What does REST means?
Backend for frontend.
Oh.
Yeah, so this is like...
So it's not big something.
No. Yeah. Okay, so thank you.